Okay, this video is about effect of high-pass filtering on data. I'm going to take the same input as the previous video, a signal with an edge, so 1, 1, 1, and then 2, 2, 2, etc. And let's assume that n is equal to 0 is here. Now, let's consider the following half-band high-pass filter. H as minus 1 over 2, 1 over 4, 1 over 2, and minus 1 over 4. And we will apply this high pass filter on this input. And y is equal to h convolved with x, or it's equal to minus 1 over 4 x of n plus 1. Plus 1 over 2 xn minus xn minus 1 divided by 4. Okay, so this is the I/O relation for this filter, input-output relation for this filter. Y0 turns out to be equal to 1 times minus 1 over 4, 1 times 1 over 2, minus 1 over 2, minus 1 times 1 over 4. So y0 becomes 0. Okay. Then y1 is also equal to 0 because we use these three samples to compute y1. Now for y2 we have a non-zero output for the first time. Okay, so it's minus 1 over 4 plus 1 over 2. Okay, minus 1 over 4 times 1, 1 over 2 times 1, minus 1 over 4 times 2, so minus 2 over 4, we can write it like that. So the result is minus 1 over 4. And y3 is also non-zero, minus 1 over 4, because 1 times minus 1 over 4, 2 times 1 over 2, 2 over 2, okay, then minus 2 over 4. So this is plus 1 over 4, and y4, we are now again in the DC portion of another DC portion of the signal. Okay, we are in the analysis window of the signal of the filter. We have only 2's, so it is minus 2 over 4 plus 2 over 2 minus 2 over 4, so it is 0, and y5 is also 0, y6 is also 0, etc. So the output, in this case, let me draw the output. Zero, 1, 2. At 2 I have minus 1 over 4 plus 1 over 4, 0, 0, 0, etc. So as you can see, the high-pass filter produces zeros for the DC parts of the signal, and it produces non-zero values for the edge, okay, corresponding to the edge or the jump in the signal. We get non-zero values and we get zeros elsewhere. So we can use the high-pass filter to detect edges or jumps in the signal. It removes the low frequency portions of the signal. You know, when I have 1, 1, 1, 1, 1, the signal produces, or the filter produces zero output, or when we have 2, 2, 2, 2, the filter again produces zero output, corresponding to the DC parts, DC portions of the input. We use the term DC, as you know, for omega is equal to 0 case in the Fourier transform.